In this video, we're diving into the Traceroute command, a powerful tool for tracing network routes to destinations. It's like having a map for your data packets, showing you exactly where they go and how long it takes to get there. Traceroute is a network diagnostic tool that displays the route taken by packets across an IP network and measures transit delays. It helps identify the path that data takes from your computer to a destination server, showing each hop along the way. Think of it as a detective that follows your data packets, revealing their journey across the internet. Traceroute works by using the time to live, or TTL, field in IP packets to discover the path to a destination. First, it sends packets with increasing TTL values starting from 1. When a router receives a packet with a TTL of 1, it drops the packet and sends back an Internet Control Message Protocol, or ICMP, time-exceeded message. Traceroute then records the source of each time-exceeded message to build the route map. For protocol variations, Linux uses User Datagram Protocol, or UDP, packets by default, using ports 33,434 to 33,534. Windows uses Internet Control Message Protocol, or ICMP, echo request packets, using the command Traceroute. Modern implementations can use Transmission Control Protocol or TCP, User Datagram Protocol, or UDP, or Internet Control Message Protocol or ICMP. The basic syntax for using the Traceroute command is simply Traceroute, followed by any options, and then the destination. For example, to trace the route to a domain, you would type traceroute.google.com. To trace the route to an IP address, you would type traceroute 8.8.8.8. Some common options include specifying the maximum hops using traceroute m, followed by a number and the destination, or setting a timeout in seconds using traceroute w, followed by a number and the destination. Here are some useful advanced options. To use Internet Control Message Protocol or ICMP echo, instead of User Datagram Protocol, or UDP datagrams. To use Transmission Control Protocol, or TCP/SYN for probing. And to not resolve IP addresses to host names. W followed by the number of seconds to wait for a response. Q followed by the number of probes per hop. M followed by the max TTL or maximum time to live, to set the maximum number of hops. For example, to use Internet Control Message Protocol or ICMP echo request packets, type traceroute.iexample.com. To not resolve host names, which is faster, type traceroute in 8.8.8.8. To use Transmission Control Protocol or TCP/SYN packets on port 443, type traceroute tp443example.com. Finally, to set 3 probes per hop with a 2-second timeout, type traceroute q3w2example.com. A sample output from the Traceroute command would look like this: traceroute to google.com, followed by the IP address, 30 hops max, and 60-byte packets. The first column of numbers is the hop number or router in the path. Next, you'll see the host name and the IP address. After that are the round-trip times in milliseconds. By default, Traceroute sends 3 probes per hop. Some special symbols that you might see include an asterisk, which indicates no response, timeout, or filtered. H indicates host unreachable. N indicates network unreachable. And X means communication administratively prohibited. Traceroute is useful for many common use cases, including identifying network bottlenecks by looking for significant latency increases between hops, locating connection failures by finding where the trace stops, detecting routing loops where the same router appears multiple times, identifying firewall blocks by finding where packets are dropped, and mapping network topology to understand the path between systems. Let's consider some common scenarios. Consistent timeouts or multiple asterisks in a row often indicate a firewall blocking Internet Control Message Protocol or User Datagram Protocol traffic. Try using Transmission Control Protocol or TCP mode with that option. High latency jumps or sudden increases in round-trip time may indicate crossing geographic boundaries or congested links. If a trace ends before reaching the destination, it could indicate a network outage, firewall block, or routing issue. Different round-trip times for the same hop may indicate asymmetric routing where packets take different paths. There are several useful alternative tools to Traceroute, including My Traceroute, or MTR, which combines the functionality of Traceroute and ping in a real-time interactive interface. It shows continuous statistics. There's also TracePath, which is similar to Traceroute, but doesn't require route privileges, and discovers path maximum transmission unit or MTU along the route. Parish Traceroute is designed to correctly handle load balancers in the network path, and is more accurate for modern networks. Finally, visual Traceroute tools are graphical user interface or GUI applications like Visual Route or Ping Plotter that provide graphical representation of network paths. Key takeaways from this video are that Traceroute helps visualize the network path between your system and a destination. It works by manipulating the time to live or TTL field in IP packets to discover each hop, and it's useful for troubleshooting network connectivity issues and identifying bottlenecks. Also, different protocol options such as User Datagram Protocol or UDP, Internet Control Message Protocol or ICMP, and Transmission Control Protocol or TCP help bypass various network restrictions, and modern alternatives like MTR provide enhanced functionality for complex networks. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.